Hi, everyone. Today marks my last episode of season 5, Make It Golden, Building Trust with Responsible Generative AI. And for this final episode, I'm happy to welcome one of FICO's own scientists, Jayson Francis. Jayson is a principal scientist here on the AID team, the AI Innovation and Development team, reporting to me. Jayson, thanks for joining me in the conversation today.
Awesome. Thank you, Scott, for having me.
So Jayson, before we get started and dive deep into like where we are with large language models and some of our philosophies around how we develop generative AI, why don't you just give everyone a little bit of a background, who you are and what some of your experiences?
I'm currently working at FICO as a AI scientist. I've been in the industry for about roughly over 12, 13 years, really doing a lot of fundamental research on ML and AI and essentially, how to leverage compute and data and, efficient software to kind of work on challenging problems and explore the space with various concepts and various technology. Yeah, it's been a really fast moving environment in the last couple of years, especially with generative AI. And so it's a fascinating aspect to kind of talk about today.
Yeah, thank you, Jayson. And yeah, I'm really happy that we get to partner on this. You know, maybe we'll just start off just talking about like, all that we've seen, right? I mean, I think one of the interesting things about generative AI and large language models is just the immense volume of information coming at us all the time, all the different developments, all the different sort of benchmarks and new ways of trying to leverage these technologies, and concepts of reasoning and general intelligence and other sort of aspirations, and the field is huge, right? And it's tough to sort through it all. And maybe I'll just start by just talking about what that means, right? Like, for example, like when we first started to talk a lot about in the field about large language model hallucinations and bias correction, right? There was a lot of sort of concern, right? And examples of LLMs getting things wrong, right? And people had wanted to focus on driving more and more sort of technology in there. And then there was this conversations about reasoning and justifications, which are really, really difficult, right? Unless you use some sort of mechanical interpretability, which is still sort of nascent in the field today. But we've seen other sort of behaviors, such as do they reason or do they not reason? Is there a confirmation bias? So they tell you what you want to hear versus what you need to hear, right? And so there's a lot there that makes it really, really, really complex in terms of how we leverage these sort of technologies. And I always take a step back and I think about the fact that so many organizations do these generative AI proof of concepts. And there was an IDC survey recently that said that like 70% of CIOs that were surveyed, said, well, 9 out of 10 custom built AI apps, don't get past the POC stage. So there was, tons of exploration, but there's tons of complexity on getting these technologies to work. And those are just some examples. So, maybe we start by just talking about a few of those, right? And what they are, and get some of your viewpoints, and I'll leap in there too, in terms of what might stop people from getting from a proof of concept to something that gets leveraged in a production way that generates value. And maybe one of the first and is RAG based technology, right? Retrieval augmented generation, where we have this sort of technology that sort of supplements LLMs with access to external data sources. Theoretically allows more accuracy, theoretically provides more access to data that is more timely. I'm just curious, what's your thoughts about RAG and the journey we've seen there in terms of the use of RAG, and does that make it foolproof? Is it part of the equation? What's your thoughts about uses of RAG?
Yeah, so retrieval augmented generation, I think, is something that is being looked at in a lot of the POCs, a lot of the, to get the innovation up and running and to get some kind of concepts up. And essentially, it's good for the short term to do some demos and to basically augment your model with additional data. the mechanism that is being in place here is essentially prompting in context learning, essentially the ability to provide information to your model, and the model adapts on that information. And so RAG is something for, it's kind of like a stopgap. It's essentially if a student is taking a test and it's, yeah, a cheat sheet that the student can reference to kind of answer your information. The problem with RAG essentially is at scale, especially in the enterprise setting, when there's a lot of moving pieces, a lot of new data, and now a lot of new information that's coming into place. RAG quickly starts to be complex, and it starts to provide a lot of overhead. It starts to, increase the amount of latency of your model. There's a lot of different moving components. So now instead of having one model to really refine and focus on, now you have a retrieval, an embedding model, a similarity metric. So these are all concepts that you have to essentially manage and take control of. But at the end of the day, it's very hard to build these models and fine tune these models. There's a lot of computation that's required, a lot of data, a lot of really unique skill sets that are required. And so RAG is essentially a stopgap until you have the capability to embed a lot of information inside your model. You can leverage RAG to kind of build a solution, to prove a solution, to demo a solution. So at the end of the day, it's helpful to experiment with and to provide some value. But as you scale up, you want to really take a lot of the information and embed that intelligence inside your model.
So that's important, right? I mean, I think the fact that to get started and not have to pre-train a model, right, or fine-tune a model, or have the GPU resource, it's useful, right? But I agree, right? Then you have a sort of what is a good RAG document, right? And what makes most sense. And we also come back to issues with confirmation bias. So I can provide a document that is the world according to the view of Scott, right? And they'll be more than happy to leverage that document. But it's one of these things which are as you say, a first step, but a lot of challenges in terms of sort of accuracy and how you use it. And I was always interested in how does it actually overcome the base programming? I remember looking at cases where people use RAG, but you're not necessarily using that in the answer, right? So you can provide it in a prompt, and maybe it gets used, and maybe it doesn't get used because these are large models that have seen tons of data. So forcing them to ignore their pre-training is really, really tough. And I think you and I have looked at studies where it just adds noise. So all right, so that's RAG, right? I think it's a great one to experiment with and get a flavor, but not necessarily an enterprise sort of strengthened way of going about it. You mentioned fine tuning. Let's talk a little bit about fine tuning. We have this sort of manual fine tuning. So, what's your thoughts on that? Right, we get a big pre-trained model, and then we say, listen, I want to make it more relevant for the problem that I want to work on. What's your thoughts about how well does that work from an enterprise perspective?
Yeah, so the first thing one would do is typically start to prompt a model. You have an existing model and you want to see the existing capabilities, and you prompt it and you give information, and you basically increase the amount of data that you give it at runtime. And so you're paying for those tokens. The more use cases that you kind of leverage this technology for, the higher your token cost. And so they're gonna come to a point where essentially there's this information that you really want to embed inside the model, so the model can essentially leverage it to reason about from different concepts and from the different entities within its pre-training data. And so fine-tuning is the process of essentially adjusting the internal model and the internal weights, going through the training process to embed some of that information within the model. And so at runtime, essentially it reduces your cost. You're not paying for your tokens at runtime, and you're improving your accuracy. So you don't need fine tuning if the model you have is achieving the performance that you want on your task, and if the cost is good enough for you. But when it comes to improving your performance and reducing your cost, fine tuning is always going to help you achieve that goal.
Got it. Yeah, and so this is a efficient way to not have to go through the entire pre-training. Let's say of a large model, but and you can improve your performance if need be. At the same time, right, we still have concerns, right, because a fine tuning is not it's not a full tuning, right? And so it's,
Yeah.
you're adjusting the weights, right? You're leaning your thumb in on some of those sort of patterns, and if done in a controlled way, it can be valuable, but not necessarily, let's say, removing the hallucinations and other things that still will occur, right? Even if you're trying to bias it towards one set of weights or versus another.
Yep. Yeah, you mentioned, there's multiple versions of fine tuning. There's full parameter fine tuning, quantization. It all depends on the amount of compute, the amount of ability that you have to really fine tune a big model. Um, but also keep in mind that fine tuning is very brittle. So you can actually destroy all the pre-training information that you do if you don't correctly fine tune a model to your particular specifications. You don't have the experimentation, the logging, the telemetry that's really needed to do the experiments correctly. And so there's a lot of challenges with fine tuning as well. But in the long run, it's a good approach to continue to personalize your models to your business needs.
Perfect. And I'm glad you brought up fragility, right? There's no perfect sort of magic key here. And, you can imagine, there's a lot of work done to build these large language models. And if you end up kind of creating a fracture in it, that will get you down the road too. Maybe the last point, and then we'll talk about our approaches, right? Is the MCP, right? And using sort of other machine learning models. Like here at FICO, we have tons of other machine learning models that can be used as input, or really interesting sort of summarizations of data that can really help an LLM have more context, right? As they
Hmm.
would be leveraged, right? And very often these MCP sort of technologies are used for sort of machine-based continual reinforcement learning. And I was just curious about your thoughts there. It seems like it's taking off like crazy, and I think it's great in some ways because it allows us to leverage sort of other assets, really really well understood machine learning models. But what's your
Yeah.
thoughts about MCP and that kind of reinforcement learning that is not just fine-tuned, it's
Hmm.
something that is going a step beyond?
Yeah. So like generative AI models, decoders, encoders, they're very useful. They're very useful in translating information to modalities, to information that humans are familiar with, like language, like visual, like speech. However, they can't solve everything. And so what happens is, if you can think of these type of models as a communication layer between your enterprise and other tools that you have available, just like our agents, our engineers, we have access to tools to get our job done. Essentially, if you could leverage those same tools and provide those tools to your models, the models can essentially improve on performance, and retrieve context data, retrieve information that they think that they need. And that's the whole concept of the MCP, model context protocol, and other agentic based systems is essentially that's standard protocol. How do you kind of take all these different APIs around the world, different apps, and build a standard for your model that your model can access them, to be able to kind of explore the space a little bit more, and to search different tools, different information, and bring that all within context to make predictions with. And at FICO, we have a lot of different models that really focus on different concepts and different tasks to produce scores, to produce predictions, and our ability to kind of leverage those models within generative AI provides the agents, provide the models a lot more context capability at runtime, without necessarily needing to fine tune. But they are fine tuned on how to use the tools, but not necessarily the information that the tools provide. So
Yep.
I think that's a very powerful concept, and it's kind of like math, like a calculator. You want the model to leverage a calculator, but you don't necessarily want it to be a calculator itself. But you want it to know how to use a calculator. That'll give you the most value at the end of the day.
Yeah, and like we had a different LinkedIn conversation, and we talked with a different guest, and it was like, this is not magic, right? Like, I sometimes like to talk about machine learning models, and like it's like a mommy bird chewing up the worm for the baby bird, right? There's a lot of sort of chewing up of worms to present the sort of the what it gets leveraged, because people somehow think it's magic, but no, it
Yeah,
can't learn everything that a tool or another model has spent time doing, but it can leverage, right? And then
exactly.
it gets really really powerful. So we have to make sure we use it for the right purposes.
Hmm.
Um, Okay, so then let's talk a little bit about our work and that of FICO around the focused language model. I mean, this is something I'm excited about, something I know you're excited about, and I'll poke through just a couple different topics here. So one of the first things that we do here with focused language models is this: we have this concept of you know first concept is we need to know what the data is, right? From a responsible AI perspective, we need to have a very, very clear sort of focus on what that data looks like. And beyond that, we also had this sort of recognition that we can build models from scratch, right? So instead of doing all that fine tuning or RAG or something else and leveraging an open source based model or some commercial large language model, build your own for a specific domain and task that makes the most sense. And the very first step of that is curtailing the training data. And so I was just curious if you had any comments about what that journey looks like for us.
Yeah, so you know, when it comes to pre-training models, how it's holistically been done is let's collect all the world's information, the whole internet, and as much as we can do and get, and let's just throw compute on it and compress that information to a model, and let's see how well the model does. That's kind of from the top-down approach. And what we've been taking is, a bottoms-up approach. Is essentially we're still leveraging, larger models, larger embedding models to essentially filter through the data and score data, but we do so in an incremental way. So we start from zero and we go up to one, and we figure out exactly what chunks of information that we need to start to capture and what type of knowledge we need to capture and incrementally include in our pre-training process. And after each incrementation, we run through evaluations and we assess how well the model's doing, what it's understanding, what it's being confused on, and then we continue to iterate on that. And so that approach basically lets us have full control and understanding of exactly what's in the pre-training data, because we have the ability to basically have the model produce output when it doesn't know. So if you ask a question that it shouldn't know, it is very confident that it doesn't know, because we have the ability to kind of reinforce the concepts that are not embedded in the pre-training data. And so that bottoms up approach gives you that ability to kind of control the pre-training aspect from that, and also makes things more efficient in terms of we can iterate a lot quicker. We can build these models a lot quicker, because we're focused on particular tasks and particular areas of interest. Right now our models don't really know much Shakespeare, but if there's a use case that we need to have Shakespeare knowledge in there, then we'll integrate that into our pre-training set, our fine-tuning set, in our full process. But that's kind of
Yeah.
how we go about building our pre-training data.
Yeah, and it's critically important, right? I mean, I think for those that are listening to us, right, it's data science 101, right? What is the data on which you build your model on? What is it representative of the problem you're trying to solve? And in some sense, instead of the boil the ocean sort of approach of having all the data possible, and talking to a crystal ball and being amazed by it, we're instead saying, hey, we have this problem to solve. There's a value proposition associated with it. This is the data that we need, right? And this is the focus that we need. And that's why we call it focused language models, because we spend all that time, and you bring it up rightly so. It's an iterative process. And we've iterated on our own focused language model, where we've gone a pass and we look at it and say, do we think that's enough? Do we want to change the focus? And we change it, right? And in some sense, it's really being thoughtful up front about what the problem is we're trying to solve, what the data should look like. And that's going to be a huge amount of whether or not these models are successful or not, past a POC or even in a POC. So I think that's critically important, and I hope everyone is looking at these problems in those ways, because if you don't have the right data in there, you're rolling dice. The other thing that we focused on, and something that you took advantage of, are optimizations. And so like DeepSeek definitely broke the sort of news channels with their models, right? Which we can go and I don't want to spend a lot of time talking about DeepSeek, but they took advantage of all kinds of different ways to optimize the way they built their model in an efficient fashion, right? It was kind of many segments, and then you use sort of optimizations, but for example, like FP8, right, or these lower precision sort of optimizations used when we build a focused language model or a small language model are really important, right? Like, do we need full precision, right, to get a more than acceptable answer? And why don't you talk a little bit about our experiences with, optimizations when we build focused language models?
Yeah, so there's really three fundamental concepts that you really need to be, aware about. Is basically the quality of data, the ability for you to scale in terms of building in that model, building in that data within your model, doing it efficiently, and then the complexity of your software. And the software complexity is the component where you wanna remove any bottlenecks that are associated with your software as hardware continues to accelerate, as data continues to grow, um, as networks continue to be optimized. At the end of the day, there are kernels in the software that need to be optimized, specific techniques that can be leveraged to trade off performance for precision and for memory bandwidth and things like that. And so um, there's constant research being done on from a applications perspective, from a software perspective, exactly what trade-offs can we do, what precision techniques can we leverage, what kernels can we optimize, what um, you know, um, yeah, trade-offs can we do from that standpoint to really continue to drive the efficiency? Because right now, the bottleneck is essentially in the software. GPUs, for instance, are utilized about 50 to 60%. And that's because there's a limitation on how the software leverages the compute. And so the more efficiencies you can improve and the ability to train your models, the more you can get out of your infrastructure and out of your data.
Yeah, absolutely. And maybe I'll leave one last point that I know that before we move on to like a big topic that I want to touch before we end, which is, we've also seen that, if you give it more inferencing time, right, you can improve accuracy, right? So it's not always bigger models, it's not always the highest precision. It could be, allowing a LM to take more time to think, right? Or
Mhm.
to, provide that sort of more iteration. So there's lots of ways where small models can be built efficiently in a cost-effective fashion, and then you can still get similar performances to models that are very significantly larger and more expensive to build. And I think it's really going to be a game changer where this may become very much a commonplace thing where you'll have a suite of these smaller language models that get leveraged. There's a lot there, right? And I think this whole space of small language models and focused language models are really, really exciting to the industry right now, and good for good reason, I think. Um, so let's end on the last topic, which is around trust scores. So it's something that I think I introduced last year at the end of the year, calendar year, and the trust score is a really powerful concept from my perspective, right? Because you don't know if it's hallucinating unless you know the answer, right? And if you knew the answer, then why are you going to talk to the machine, right? And so we have to develop a level of confidence, and we've developed here at FICO a trust score, and that trust score is leveraging the same data set that we would use to build this focused language model. It has knowledge of that data set, right? But it says, what are these knowledge anchors that describe the problem that we're trying to solve? So, if we're trying to have a focused language model related to financial scams, which are a huge problem. Okay, what are the knowledge anchors in terms of what the knowledge of this model needs to look like, in terms of how scams occur and what you should do to maybe stop those scams, right? Or what do those patterns look like when someone is being scammed? And so we define knowledge anchors, and from those knowledge anchors, we can say, great, those are the facts or the skeleton of truth that this has to align with. And we say, well, what's the coverage in our training data? So is there enough representation of that in the training data? And then also we say, when someone asks a query or a prompt, how close is the prompt related to these knowledge anchors and the answer, right? And we produce a score, and that score it ranges from 1 to 999. The larger the score, the more aligned it is with the knowledge anchors, the truth that we've defined, and also, have a huge amount of coverage. And so there's a lot of confidence from a statistical perspective. And we feel that is going to be a strong sort of differentiator. And the reason for that is because you can go get the best inference from one of these large language models or focused language models, but then you have a score, and that score can basically give you an independent evaluation of whether or not you should trust the model or not, based on how well it's aligned. And it's an iterative process in terms of what those knowledge anchors are also. And so it's important because then you can operationalize it, right? You can basically say, that you could, if you have a high trust score, leverage it. If you have a low trust score, don't. And if you have a medium trust score, do something else, right? Maybe you fall back or go to more iterations. So maybe the final question to get your input on, Jayson, is, what do you think about, the trust score, right? And what's that going to do when we look particularly at enterprises, right?
Mhm.
And the fact that they need to have a way to really understand and feel comfortable in using technologies like generative AI beyond the POC. We're no, but in their day-to-day business as enterprises, what do you think that impact could be, leveraging items like trust scores?
Yeah, significant. I think, there's two really challenges. There's a technology challenge and then there's a trust challenge. And at the end of the day, you need to build capabilities to kind of reduce that gap. And the models can say one thing, but it's the business that believes another thing. And so, you want to there's for example, there's leaderboards and evaluations that are being done to kind of provide some type of proxy to the business to give them some kind of confidence and, oh, the model is doing good. But what happens when, as time progresses, your evaluations become, lagged and delayed, and your leaderboards get, gamed. Essentially, you need some type of mechanism to produce the model can produce some types of confidence or some type of score to really assess, what type of prompts are coming in as well as the responses that are coming in. And actually, this is really the, RLFT, reinforcement learning with human feedback is essentially, models, reward models that basically take in as input the prompt, take in as input the response, and produce a score. But what we're using is some more sophistication between leveraging our data and looking at coverage statistics, as well as embedded statistics that the model architecture produces itself, to combine all these aspects into a trust score. And so, provide from an operational perspective, providing the ability for business to better trust the output is always going to benefit in the long run, especially when you start deploying these models not just from customer facing, but also through agentic workflows and through autonomous processes that really move data, read and write information across your databases. You want to have some confidence in the model doing what it's supposed to be doing at all times. And so it's a good signal to kind of maintain and operate. Same thing with
Yeah.
kind of your throughput. Same thing with your latency. Your trust mechanism is something you also need to monitor over time.
Yeah, and the theme of this entire series is, and we're in a golden age, but how do we keep it golden? And being able to trust and operationalize risk and be more or less risk averse without having to rebuild a model, but simply, making it tougher to having a tougher threshold under which you leverage the output or not. I think will be game changing, right? I really think it's going to be critically important to enterprises. We focus on financial services, right? They're used to risk, operationalizing risk, and that's that's what we do all every day, right? And
Yeah.
I think this is one of the things that will help us move from POCs to successful, sustained value of these sort of technologies. And I'm just thrilled about it. And Jayson, I appreciate you, one, being on this program, and two, sharing some of your insights and a little bit of inside baseball into the stuff that we're doing here at FICO, to kind of really help drive the proper operationalization, trust, responsible use of generative AI technology. So, Jayson, thank you for joining me.
Thank you so much for having me. Appreciate it. And, I'm excited for what the future has.
Thank you, Jayson. And thank you all for tuning into season 5 of this LinkedIn series. Um, I'll be back soon with season 6. I just have to figure out what we're going to focus on. There's so many different new types of things that we can bring and talk about. But I appreciate everyone listening in, and we will be keeping it golden. Thank you.